Indices is a process of expressing numbers in exponential form. So if you have something like this, let's say a raised to power x. This is a raised to power x. In this form, this is a raised to power x. The a here represents the base. The a here represents the base. X here, it represents the power. You can call it power, or you call it the order, or you call it the exponent, or you call it the index. X represents, you can call it power, order, exponent, or you can call it the index, while A represents the base. So let's look at the laws that govern indices. Laws that govern indices. Let's look at the first law, which we call the multiplication law. Laws of indices. Laws of indices. The law that's called multiplication, call it the multiplication law. In multiplication law, we have, for example, we have a raised to power x multiplied by a raised to power y. This is a raised to power x multiplied by a raised to power y. So in this case, you can see the expression here. A here is the base. They have the same base. Since the base are the same, all we need to do is to collect it, to express it A, and add what? Add the powers, become A raised to power x plus y. Give us something like this. This is multiplication. Let's take a typical example. We say example of this. If we have, let's say 3 raised to power 4 multiplied by 3 raised to power 5. It is equal to 3. You take the common base, then you add the powers, become 4 plus 5. So this thing gives us what? 3 raised to power 9. 3 raised to power 9. 3 raised to power 9 means 3 and you multiply 3 in what? 9 places. For example, we have something like this. This 3 raised to power 9 means 3 times 3 times 3 times 3 times 3 times 3 times 3 and times 3. We have 1, 2, 3, 4, 5, 6, 7, 8 and what? 3. This is 3 in what? 9 places. That's what means by 3 raised to power what? 9. Are we together? So let's look at another law we call the division law. Division law. In division law, here we can have, let's say a raised to power x divided by a raised to power y. So in this case, it gives us a, we take the common base and we subtract the powers. A raised to power x, take away y. That is division law. You take the common base and you subtract what? The powers. Subtract the powers. Subtract the powers. Example, let's see an example on this case. For example, if let's say 6 raised to power 7 divided by 6 raised to power 4. In this case, 6 raised to power 7 divided by 6 raised to power 4, it is equal to 6. You take the common base, 6 raised to power 7, take away what? 4, and gives us 6 raised to power 3. 6 raised to power 3, because 7 take away 4 is 3. So that is our division law. Division. So let's look at another law we call the zeroth law. the zeroth law. In zeroth law, it says that a number, when a number raised to power 0 is equal to 0, a number equal to 0 is what? 1. Let's take what? A raised to power 0 is equal to 1. As long as what? A, provided A is not equal to what? A is not equal to 0. Provided that A is not equal to what? 0. Provided that A is not equal to what? 0. So let's see, if you have, let's say 9 raised to the power 0 is 1. 3 raised to the power 0 is 1. That is what zeroth law talks about. Zeroth law talks about. So let's look at another law we call the negative law. Negative law. Or we call it negative index. In negative index, for we have a number, let's say a raised to the power what? A raised to the power x. A raised to the power minus x. In this case, this minus here, a raised to the power x becomes 1 all over what? A raised to the power x. Are we there? We have 1 all over a raised to the power x. So that is the expression. For example, we have, let's say 9 raised to the power minus 2. 9 raised to the power minus 2, it is equal to 1 all over 9 raised to the power 2, and it's equal to 1 all over what? 9 raised to the power 2 is equal to 81. So the answer here is what? 1 all over 81. 1 all over 81. So let's look at another law. Here we talk about the distributive law. Distributive law of indices. In this case, if you have a number like a raised to the power x, bracket close, raised to the power y, a raised to the power x, bracket close, raised to the power y, in this, all we need to do, the power, you can see this power is what? Is outside the bracket, it's outside. So automatically this power affects all the terms that are inside the bracket. So in this case, it gives us a raised to the power x, give us a raised to the power x multiplied by y. So it becomes a raised to the power x y. A raised to the power x y. So let's look at an example. If you have something like this, you have 3 raised to the power 2 raised to the power 4. So look at it. The solution here, solution to this problem is that 3 raised to the power 2 raised to the power 4 is equal to 3 raised to the power 2 multiplied by 4. So it gives us 3 raised to the power what? 8. 3 raised to the power 8. So that's what you have. 3 raised to the power 8 it gives you. So let's have another example. Let's look at another example where we can solve this kind of problem. Let's look at an example on this. For instance, we have 3x, y raised to power, let's say this is 2, and this is 4 raised to power what? Power 3 outside. This is what we have. So you can apply this. You can apply this. You apply this. How do you solve it? If you ask to solve this problem. So you can see in this problem here, the 3 that is outside the bracket, it affects all the components of this expression. It affects all the components inside the bracket. Because this 3 now is distributed to all the components in the bracket. So how do we solve this problem? So it's a solution. So we have, this is 3 raised to power 3, because there is an invisible 1 here. There is an invisible 1 here. These 3 contain an invisible 1. So you can just put it 1 times 3 multiplied by x, 4 times 3 multiplied by y, 2 times what? 3. So that's what we have. So it's the same thing as 3 raised to power 3, x raised to power 12, y raised to the power 6. So that is the solution of this problem. So let's look at fractional indices. Fractional indices. That is an index where the power has what? A fraction. For example, let's fractional index. So let's look at this one. If you have a raised to the power x raised over y. So you can see that the power, in this case, the power is what? The power is x all over y, while the base is what? A. So how do we solve this problem? So to solve this problem now, you say, you take the root, it becomes the root of a, this thing now becomes the root of the y root of what? Of a raised to the power of x. Y root of a raised to the power of x. That's what we have here. So for example, if you have, let's say we have 32 raised to the power of 2 over what? 5. 32 raised to the power of 2 over 5. So in this case, we have, how do we solve it? We take the fifth root of 32, sorry. We have, this is the fifth root, because the denominator of the fraction is what? Is the root. So we have the fifth root of 32, then raised to the power, the numerator is what? Is the power. So in this case, remember the fifth root of 32 is what? Is 2. So in this case, we have 2 raised to the power 2. 2 raised to the power of 2. And 2 raised to the power of 2 is what? 4. So 32 raised to the power of 2 over 5 is what? Is 4. So that's what we have. So for example, if you have, when the fraction now have what? A negative value. So let's see. Example, we have 32. Let's say 32 raised to the power of minus 2 over 5. Look at what we have. In this case, remember when we talked about the negative index, in this thing becomes 1 all over 32 raised to the power of 2 over 5. That's what. So the next thing you do, you say 1 all over fifth roots of 32 to the raised to the power of what? 2. So finally, you have 1 over, because the fifth root of 32 is 2, and 2 raised to the power of 2 is what? You have 2 raised to the power of 2, and give us 1 all over what? 4. 1 over 4. So that is what we have.